In today's video, I'm going to talk about Lecture 3, Superposition Theorem on DC fundamentals. So what is Superposition Theorem? Superposition Theorem is the method that we use to determine the total current through or the voltage across a resistor or branch. It's determined by adding effects due to each source acting independently. So the method we use, we remove all the source other than one being examined, replace the voltage source with a short circuit, and we replace the current source with the open circuit. Find the result of branches using each source independently. After that, we algebraically combine results. So example 1, in this example, the circuit contains two voltage sources, E1 and E2. The amount of current flow through R2 is determined using superposition theorem. The circuit can be solved by the following procedure through several distinct steps. So we have E1 and E2, we have three resistors, R1, R2, R3. We try to find the current through I2. So the step is we try to replace each power source with a short, and after that we find the current for each power source acting independently. After that, we just algebraically combine the result. So the step 1 is we replace E2 as a short. Now we have a combination circuit, which is R2, R3 in parallel, and then in series with R1. So for the parallel part, our parallel resistance will be 1 over R2 plus 1 over R3. That will be 1 over 300 ohms plus 1 over 1200 ohms. So the total will be 300 times 1200 divided by 300 plus 1200. That will give us 36,000 divided by 1500. That will give us 240 ohms. So that's the resistance for this part. And the total resistance RT will be R1 plus R parallel, which is 600 ohms plus 240 ohms, which is 840 ohms. After we get RT, by using Ohm's law, so here Ohm's law, we can find the total current. And after we get this is the total current. After we get the total current, we can get the voltage that for this part, for the parallel part. So the parallel resistance is 240 ohms. So the voltage for this part will be E equals I times R. So we have IT times R parallel, which is E combination. This is IT times the parallel part. That will give us 6.864 volts. After we get the voltage for this part, we can get the current through R2, which is Ohm's law again. So we use E divided by R. That's the current flow through R2. And this is a positive direction here. And the second step is we replace E1 with a short. Now we have R1, R2 in parallel. And in series with R3. So if we define the current direction as this way, that all possible will go this way. So we have the parallel resistance, so R2 will be R3 plus R1 and R2 in parallel. So the total resistance is 1400 ohms. And after that, we can get IT by using Ohm's law. After we get IT, we can get the the voltage for the parallel part, which is E combination. We use IT times the parallel resistance. So the parallel resistance was this part. So that will be 1 over 300 plus 1 over 600 and flip it. So that's 200 ohms. Then the E combination will be 1.714. After we get the E combination, we can get the current for R2. So that will be this direction, and E, we use Ohm's law here. E divided by R, which is the current here, 0.00571 amps. So the direction is also going up. So we get two currents, both go up through R2. So the last step is we algebraically combine the two currents that we get. So step 3. The next step is to find the algebraic sum of the two currents. Because both currents flow through R2 in the same direction, the two currents are added. So I2 total is the first current for R2 plus the second current for R2. They have same direction, they both go up. So it's addition. So the total current flow through R2 will be 0.0286 amps. Or we could convert it to milliamps, that would be 28.6 milliamps times 1,000. You want to change amps to milliamps. So that's how we change the unit for the current. So if we have 1,000 milliamps, that will be 1 amps. If we have 1,000 microamps, that will be 1 milliamps. So the difference is 1,000 10 to the 3. So from 1 amps, we can change it to 1,000 milliamps. We can change it to 10 to the 6 microamps. Now let's look at another example, example 2. This circuit contains a voltage source of 30 volts and the current source of 0.2 amps. The amount of the current flowing through R2 will be calculated. So we're trying to get the current for this guy, R2 here. So the step 1 is we replace the current source with the open circuit. Now there's only one branch here. So the total resistance will be R1 plus R2. Then we can get IT by using Ohm's law. So that will be E source divided by RT. So RT is 350 ohms. IT will be 30 volts divided by 350 ohms, which is the current here, and the positive direction is like this. This is I. And the step 2 is we replace the power source, the voltage source with a short. So we have a parallel circuit. If we use the current divider, we can find the current through the R2 resistor. So the direction will be like this. If we define this way as positive, this way will be negative. So I2, if we use current divider, it's R1 divided by R1 plus R2 times IS. That's the total current. After we plug in the number, we can get I2 equals 0.143. So the other way we can get the current for R2 is we can get the parallel resistance. So the parallel resistance 1 over R1 plus 1 over R2. That will give us 1 over 250 ohms plus 1 over 100 ohms. So that's 250 ohms times 100 ohms divided by 250 ohms plus 100 ohms. 2530 divided by 350. 7.4 ohms. And then we can get the voltage by using Ohm's law, parallel times I2. That will give us, so we use 71.4 ohms times the current source 0.2. That will give us 14.3 volts. And we can get the current for I2. It'll be E divided by R2. So that's 14.3 volts divided by 100 ohms. That's also give us 0.143 amps or 143 milliamps. So that's how we use Ohm's law to solve the current here. So we get the total resistance, then after that we get the voltage, then we use Ohm's law again. I equals V divided by R. So 14.3 volts divided by 100 ohms. That will give us the current. After we get this current, we can just add them together. Since the total amount of current flow R2 can now be determined by finding the algebraic sum of the both currents. So for the current source, the current is going down. For the voltage source, the current is going up. So the algebraic sum will be, this guy should be minus sign. So it will be this one, 0.143 minus 0.0857. So the result is not right on the slide. Since they have different directions, so one goes down, the other one goes up. So the algebraic sum will be, this one will be the minus sign. So that will be the difference of the two. The result will be 0.143 minus 0.0857. So that will give us 0.0573 amps. That will be 57 points. That would be 57.3 milliamps. So for the superposition theorem, doesn't apply to the power. When we calculate the power, we gotta find the current first, then determine their power. So we find the current first, then we have the resistance. We use P equal to I squared R or V squared divided by R in order to find the power. So that is everything about superposition theorem. I hope you guys know how to do the calculation now. Thank you for watching.